Welcome back to the Deep Dive. Today, we are probably going to ruin action movies for you.
Or maybe make them more interesting, depending on how you look at it.
That's true. But we're also going to make you look at your front door a little differently tonight. You know that sound, that heavy thunk when you throw the deadbolt on your front door.
It's the sound of safety. Or at least that's what we're conditioned to believe.
Exactly. You hear the click, you check the handle, it doesn't turn, and your brain just goes, okay, I'm secure, the world stays out there, and I stay safe in here. But we had this stack of documents today. Police manuals, the famous MIT guide to lockpicking, locksmith training logs, that suggest that sound is, well, basically a lie.
I wouldn't call it a lie necessarily, but it is an illusion. We're diving into the engineering of barriers today. And the reality is, for a professional or a knowledgeable intruder, that deadbolt isn't a wall, it's a puzzle.
Right.
And it's a puzzle that relies on physics, on manufacturing errors, and, a little bit of luck to keep you safe.
Wait, manufacturing errors?
Oh yeah, we'll get there. It's actually the most mind-blowing part of how locks work. But essentially, we're going to unpack how locks work, how they fail, and what actually counts as high security, especially here in Los Angeles.
I'm ready to be paranoid. But before we break into the mechanics of picking, we should probably talk about who to call when you actually want that lock to do its job. Because after reading this research, I realized my DIY hardware store lock just isn't cutting it.
Yeah, if you're in Los Angeles, the gold standard is West Point Locksmith.
We're talking 5-star reviews and genuine 24/7 availability. They handle everything from emergency lockouts, because we've all been there, to the kind of high-security upgrades we are going to talk about today.
You should have their number in your phone. It's 310-295-4040.
And honestly, with the complexity of modern locks, this is not a field for amateurs. You need a pro.
Absolutely.
That's West Point Locksmith at 310-295-4040. Fast, reliable, professional. Don't wait until 2 a.m. to put that number in your phone. So let's start with the object in your pocket, the key.
Okay, so the Flatland model. This comes straight from the MIT guide to lockpicking.
Right. The MIT guide is legendary in these circles because it breaks down the lock not as a security device, but as a mechanical system. To me, a key is just a jagged piece of metal. I stick it in, I turn it, it feels like one motion. But the guide breaks this down into something called the pin-tumbler. What is actually happening inside that little slot?
So visualize the lock cylinder, the part the key goes into, as a plug that needs to rotate inside a shell or a hole.
Okay, plug and hole. Got it.
Now, drilling down from the top of the hole, through the hole, and into the plug are a series of shafts, usually 5 or 6 of them. And inside those shafts are springs and little metal pins.
And these pins are what's blocking the plug from turning.
Exactly. Think of them like tiny deadbolts. And there are actually 2 pins in each shaft. You have the key pin, which is the one that touches your key, and then the driver pin, which sits on top of that. So when there's no key in the lock, the springs push those driver pins down so they straddle the line between the plug and the hull.
So the lock is physically jammed by these little metal cylinders?
Correct. You can't turn the plug because there is solid metal in the way.
So the key, it's basically a map.
It's an instruction manual for the pins. Yeah. The jagged cuts on your key are essentially an elevation map. When you slide the key in, it pushes those key pins up. If it's the correct key, it pushes them to the exact height where the gap between the key pin and the driver pin aligns perfectly with the edge of the plug.
The shear line.
The shear line, exactly. When all 5 or 6 of those stacks line up at that shear line, the obstruction is gone. The plug can turn.
It's an alignment game.
Yeah.
You need 5 things to be in the perfect spot at the same time.
Yes.
Which brings me to the thing I just could not wrap my head around in the reading. If you need 5 pins to be at exact different heights all at once to turn the lock, how on earth does a lockpick work? You're going in there with a piece of wire, you don't know the heights, can't lift them all at once.
Okay. This is where we get to the binding defect. This is the secret.
This is the manufacturing error you were talking about.
It is. In a theoretical perfect a world of, pure geometry lockpicking would be completely impossible. If every hole was drilled perfectly down the center line and every pin was machined to the nanometer, you couldn't pick it.
Because you'd have to guess the combination perfectly all at once.
Right. But we don't live in a perfect world. We live in a world where drill bits wander slightly, where metal has tolerances. The MIT guide calls this necessary sloppiness.
Sloppiness. I love that.
Yeah. Because of these tiny microscopic imperfections, the holes aren't in a perfect straight line. Maybe hole number 3 is 0.001 inches to the left. Maybe hole number 1 is a tiny bit forward.
Okay, so they're jagged. How does that help a thief?
It changes everything. When you apply torque, when you use a tension tool to try and turn the plug before the pins are set, the plug tries to rotate, but it hits the pins.
Right, it hits that metal jam.
But because the holes aren't perfect, it doesn't hit all the pins at the same time. It hits one pin first, the one that is furthest off center.
The binding pin.
Exactly. That one pin is now taking all of the load. It binds, it gets stuck. The other pins are still loose. You can jiggle them up and down. But that one binding pin feels stiff.
So the lockpicker finds the stiff one.
You find the stiff one, you lift it gently until you feel a little click. And you feel the plug turn a tiny fraction of a degree. Now that pin is set.
And because the plug turned that tiny bit,
now a different pin is hitting the edge. A new pin binds.
that is unbelievable. So you aren't guessing the combination. You're letting the lock tell you the order.
You are exploiting the fact that the lock is imperfect. You just pick them off one by one, find the bind, lift, click, find the bind, lift, click.
So it's not about dexterity, really. It's about feeling that feedback.
It's a mechanical interrogation.
That makes the guy in the movie who opens the door in 3 seconds with a paperclip seem, well, actually, this still seems fake. Single pin picking takes time, right?
Mm-hmm. It takes patience, yeah, but the movies aren't entirely wrong. They're just usually showing a different technique called raking or scrubbing.
Scrubbing. This sounds less elegant.
It is. I mean, think of single pin picking as a sniper shot. Raking as a machine gun. You use a tool with a wavy edge or rake, and you basically jam it into the keyway and rip it back and forth over the pins violently while applying tension.
You're just mashing them.
You're playing the odds. You're bouncing the pins up and down so fast that statistically they will momentarily jump to the shear line. If you're applying tension at that exact split second they jump, they get caught.
It's brute forcing the probability.
And on a cheap standard lock, it's terrifyingly effective. You can rake open a low security padlock or a basic front door deadbolt in seconds.
The sources also talked about pick guns. And I love the analogy they used here. Pool balls.
Physics in action. It's just Newton's laws.
Explain this. Because a gun sounds like you're shooting the lock.
It's more of a snapper. It's a metal strip that snaps upward very hard. So think about a pool table. You have the cue ball and the 8-ball touching each other. If you hit the cue ball, it stops dead and the 8-ball just rockets away.
Right, transfer of energy.
Kinetic energy transfer. A pick gun or even a bump key strikes the bottom pin, the key pin. That pin doesn't move much, but it transfers that shock wave to the top pin, the driver pin, and the driver pin just flies upward, compressing the spring.
Creating a gap.
For a split second, gravity and the springs are defeated. There is a gap at the shear line. You turn the plug while that's happening, and the door opens.
And bumping is the same principle.
Bumping is just the manual version. You get a specially cut key cut to the deepest possible setting, stick it in, pull it back just one click, and then whack it with a hammer or a shoe.
A shoe.
Yeah, anything heavy. It sends that same shockwave through the pins. It's loud, it's violent, but it leaves almost no trace.
That's so disturbing. But there was another method in the police manual that didn't even involve the pins at all. The mica shim. This is the credit card trick.
Basically. But pros use a flexible sheet of mica or plastic. This targets the latch, not the lock cylinder itself.
And this only works if you don't have a deadbolt, right?
Correct. If you only have a knob lock, the one with the slanted latch, the angled side is meant to push in when it hits a strike plate so the door can close easily.
Right.
Well, if I can slide a thin piece of plastic between the door and the frame, I can just push that slanted latch back manually. The lock cylinder effectively doesn't matter. I've bypassed it completely.
Which is why the source material says deadbolts are just non-negotiable.
If you don't have a deadbolt, you don't have a lock. You have a privacy latch.
Speaking of bypasses, I have to bring up Slim.
The legend.
This was from one of the CLK Supplies interviews. A locksmith talking about his mentor, a former cop named Slim.
Because he was a wizard with the Slim Jim?
I always thought Slim Jims were just for cars. But the source said he was opening 18-wheelers.
It's all about linkage. I mean, a Slim Jim is just a flat piece of metal with a hook. You slide it down into the door panel, and you're blindly groping for the rod that connects the lock button to the actual latch mechanism. You grab it, you yank it, and the door unlocks.
It feels like the Wild West. You have hammers, shims, hooks. It really makes you realize that standard locks are they're fragile. They're vulnerable to physics.
They are. They're really designed to keep honest people honest.
So let's pivot. If standard locks are just puzzles waiting to be solved, what makes a lock high security? What am I actually paying for if I upgrade?
You're paying for engineering countermeasures. You're paying for a lock that actively fights back.
Okay, give me an example. How do you stop someone from picking?
You change the shape of the pins. Standard pins are just simple cylinders. High security locks use security pins. The most common one is the mushroom or spool pin.
Like a spool of thread.
Exactly. It has a narrow waist. So imagine our lock picker. He's applying tension. He starts to lift the pin. But instead of the whole pin setting, the narrow waist of the spool gets caught on the edge of the hole.
Like it's snagged.
And the plug turns just a tiny bit. The picker thinks, yes, I got it. This is called a false set.
That's a trap.
It's psychological warfare. The picker thinks the pin is set, but the lock is still locked. To fix it, he has to push the pin up even further, which forces the plug to rotate backwards against his tension tool.
Which probably drops all the other pins he already set.
Exactly. It resets his progress. It turns a 30-second job into a 10-minute nightmare.
What about the brute force stuff? Like drilling?
Hardened steel. High security locks have anti-drill plates or hardened ball bearings inserted into the face of the lock. You try to drill it, and your bit hits a piece of metal that is harder than the drill bit itself. The bit just shatters or spins harmlessly.
And then there's key control. This seemed like a really big deal for businesses.
It's huge. If you give your house key to a dog walker or a contractor, they can go to any hardware store and copy it for $2. You have absolutely no control.
So how do you stop that?
Restricted keyways. The manufacturer patents the actual shape of the keyhole, the zigzag profile. Then they strictly control who gets the blank keys. A hardware store literally cannot stock them. They would be sued.
So if I have a high security lock and someone steals my key, they can't just go copy it.
Not without authorization cards and matching ID. It prevents that unauthorized duplicate attack.
This is the difference between like a $20 lock and a $200 lock.
It is, but you have to remember the strongest lock in the world is useless if the door frame is made of balsa wood.
Installation matters.
It's everything. If the strike plate, the metal bit the bolt goes into, is just screwed into the trim with half-inch screws, one solid kick will split the wood. You need 3-inch screws that go all the way into the structural stud of the house.
Which brings us back to our sponsor. Because I'm listening to this and thinking, I have no idea if my strike plate screws are 3 inches long.
Most people don't. That's exactly why you call West Point Locksmith.
If you're in LA and you want to know if your security is an illusion or if it's the real deal, call them. 310-295-4040. They do commercial upgrades, residential rekeys, and they know about spool pins and anti-drill plates.
Seriously, just give them a call.
West Point Locksmith. 310-295-4040.
You know, speaking of the difference between pros and amateurs, the stories from the field in these sources were just hilarious.
The human side of locksmithing.
It's not just metal and springs, it's people making mistakes.
I loved the Lockfather story. This was from a locksmith's vlog transcript, right?
Yes. So this apprentice is trying to impress his boss, who he calls the Lockfather. He's engraving a machine or a plate to sell to him, and he means to write the word country.
Country.
Simple enough. But whether it was a slip of the finger or an autocorrect, he engraves county, no R.
Oh, no.
He presents it to the Lockfather. The boss looks at it, shakes his head, and just says, I would have bought it if it said country, but county deals off. But it teaches a lesson, you know. In locksmithing, precision is everything. If a pin is off by 1,000th of an inch, the key doesn't turn. If a word is off by 1 letter, you lose the sale.
And then there was the handcuff trivia. I think this ruins cop movies even more than the lock-picking stuff.
Handcuffs are fascinating because they are mass-produced restraints. Your standard cuffs, Peerless, Smith & Wesson, they are not high security.
The source said you can open them with a ballpoint pen.
Or a bobby pin. The mechanism is a simple ratchet. There are no complex pins. You just need to slide a shim in to lift the ratchet arm off the teeth, and it pops right open.
Is that why police double lock them?
Right. There's a little pin on the side you push in with the key that freezes the ratchet so it can't be shimmed as easily. But yeah, don't rely on movie cuffs for any real security.
Now, looking at the 2025 trends report we have, the whole industry is shifting. We aren't just talking about metal anymore. We're talking about all keys lost.
AKL. In the automotive world, that is the nightmare scenario.
Yeah, it used to be you lost your car key, you just cut a new piece of metal.
No. The key is a computer. It has a transponder chip that talks to the car's immobilizer. If you lose all the keys, the car basically turns into a very expensive brick.
The process described in the source sounded like pure hacking.
It is. A locksmith has to come out, use a special leashy tool to manually decode the door lock just to cut a blade, and then they have to hook a programmer into the car's OBD port, the diagnostic port, to tell the car's brain, hey, accept this new key.
And if you do it wrong,
You can brick the computer or wipe all the data. It requires serious training. This is why the DIY approach on modern cars is so dangerous.
the source explicitly said, do not try to Slim Jim a modern car.
Oh, please don't. Modern car doors are packed with electronics, sensors, window motors, and crucially side impact airbags.
You shove a metal rod down there.
You could sever a wire harness, which is thousands of dollars to fix. Or worse, you could trigger the airbag deployment. Imagine an airbag going off in your face while you're looking through the window.
Okay, noted. Call the pro. But what about the future of the front door? The trend report mentions biometrics and AI.
We're moving from what you have, which is a key, to who you are, a fingerprint or a face.
It sounds convenient.
It is. But the integration of AI is the really interesting part. The report talks about pattern recognition. The lock actually learns your habits.
So if I come home at 6 p.m. every day,
The lock expects you.
right?
But if suddenly someone tries to input your code at 3 a.m., or from a weird angle, or after 5 failed attempts, the AI flags it as unusual, it might disable the keypad or send an alert to your phone.
It's an intelligent barrier. But doesn't that just introduce a whole new set of vulnerabilities?
Yeah.
We started this episode talking about picking physical pins. Now we have to worry about hackers.
That is the trade-off. The trend report emphasizes cybersecurity in locksmithing. A lock is now an IoT device, an Internet of Things device. It has firmware, it has an IP address.
So if I don't update my front door's firmware, someone could theoretically hack it from their couch.
Theoretically, yes. You don't need a pick gun, you need a script. The locksmith of 2025 needs to be half mechanic, half IT support.
It almost makes you nostalgic for the dumb mechanical deadbolt.
There is something to be said for a lock that can't be hacked over Wi-Fi. Also, we're seeing a rise in eco-friendly security.
Right, I saw that. Recycled materials.
Yeah, lock bodies made from recycled brass and steel, and mobile locksmiths switching to electric fleets. It's a small trend, but it's growing.
Let's ground all this for the listener. We've covered everything from picking physics to AI. I'm looking at my door. I want to be safe, but I don't want to spend a fortune. What is the one big takeaway?
Rekeying.
Explain that.
People think if they lose a key or move into a new house, they have to go to the hardware store and buy all new locks.
New handles, new deadbolts, the whole set. It's expensive.
And totally unnecessary. A locksmith can come out, take your existing lock apart, and just change the pins inside.
They changed the combination.
Exactly. They just drop in new pins that match a brand new key. The old key is now useless. It costs a fraction of the price of replacing all the hardware, usually something like $70 to $160, depending on how many locks you have.
That is a massive money saver.
And it's sustainable. You keep the hardware, you just change the logic inside.
So if you've just moved or maybe gone through a breakup,
Rekey, don't replace.
and if you are going to do that, you know who to call.
West Point Locksmith.
310-295-4040. Whether it's rekeying, high-security installation, or rescuing you from a car lockout without setting off the airbags, they are the experts in L.A.
Call them. 310-295-4040.
We've gone from the flatland model, simple geometry, to AI-driven biometric systems. It really feels like a constant arms race.
It is. It's a race between the engineers trying to create a perfect barrier and the rest of the world trying to find that necessary sloppiness.
That phrase really stuck with me.
Because every lock, no matter how high-tech, relies on a mechanism that has to allow someone in. And if there is a way in...
There is a way to exploit it.
Exactly.
So here is the thought I want to leave you with. If every mechanical lock has a tolerance, and every digital lock has a potential code bug, is there such a thing as a truly unpickable lock? Or are we really just buying time?
I think at the end of the day, we're just buying time. But sometimes 5 minutes is all you need.
Look at your key a little differently when you get home tonight. Thanks for listening to The Deep Dive.